So why don't we go ahead and fill in this table by substituting in the given x and y values. That'll help us find 3 points on our line and allow us to graph our line. Quick sidebar, in order to graph any line, you need 2 points. So if I only had 1 point, how many lines could I draw through that? I could draw infinitely many lines through that 1 point. But if I have 2 points, there's only one possible line I could draw through those 2 points, right? One possible straight line, and that's what a linear equation in 2 variables is. So let's clear all those markings and start by substituting in the x value of -1. So what I'm going to do is I'm going to plug in -1 into our equation. So I have 2 times x, but instead of x, I'm going to substitute in a -1 plus 3y equals 6. So I'm going to go ahead and simplify this equation. So I'm going to take 2 times -1, it's going to be -2 plus 3y equals 6. Now in order to solve for y, friendly reminder, we want to isolate our variable, and I can do that by combining like terms. So I'm going to add 2 to both sides because those are my constants. That leaves me with 3y equals 8. Next, I need to get y all by itself. I want it to have a coefficient of 1. Right now its coefficient is 3. So I need to divide both sides by 3. That means y equals 8/3. So I'm going to go ahead and say y equals 8/3, but that's kind of hard to know what 8/3 look like. So I'm going to write that as a mixed number. So 3 goes into 8 2 times with a remainder of 2 left over. So it's 2 2/3. Okay, so now I have when x is -1, which is over here, y is +2 2/3. So it's something right there, I would say. Now let's figure out the x value when x is 0. If I take 2 times 0 plus 3y equals 6, that is just going to leave me with 3y equals 6, because 2 times 0 is 0. Any number times 0 is 0. To get y by itself, I divide both sides by 3. I have y equals 2. So when x is 0, y is 2. So here's where x is 0 and y is 2. So I've got this point right there. Now, I said you only need 2 points in order to know how to graph a line, but I want to fill in this table. So why don't we go ahead and solve for the last one. Let me just erase this guy. Goodbye. Okay, so I'm substituting in for y. Okay, it's going to be more typical that we substitute in for x, but I wanted us to know that it doesn't matter. We can plug in either x or y. So if I have 2x plus 3y, but this time y is 5, equals 6. That means 2x plus 3 times 5 is 15, equals 6. I subtract 15 from both sides. That leaves me with 2x equals -9. I divide both sides by 2. So I have x equals -9/2, which is also -4.5 if we were to write that as a mixed fraction. So I have when x is -4.5, so here we go, -1, 2, 3, 4.5, right there. Y is 5, 2, 3, 4, 5. There. So there we have a third point on our line. We really only needed 2 in order to graph this equation. So why don't I go ahead and draw the line? And I have to draw the line. Why is that? Well, these 3 points aren't the only solutions to this equation. Every single point on this line, if I was to plug it in, if this had been a really accurate graph, it would give me a true statement and would be a solution. Now, what does that mean? Why don't we go ahead and plug in a point we know is on the line, which is when x is 0, y is 2, and I'll show you what it means to satisfy an equation. So if I plug in to my equation, I've got 2 times x, which is 0, plus 3 times y, which is 2, equals 6, and I solve both sides, I'm going to get that 6 equals 6. This is a true statement, right? And when I get a true statement, that means this ordered pair satisfies the equation, i.e. it's a solution. Okay? The x-intercept of a straight line and the x-coordinate of the point where the graph crossed the x-axis is going to have the form x, 0. Okay, so x value 0. These are important things for us to know. Our x-intercept is where our line crosses the x-axis. Our y-intercept is where our line crosses the y-axis. Okay? On the y-intercept, we're going to have some x value. We're always going to have an x value of 0, right? Because here's where x is 0. And then whatever y value we have. For our x-intercept, my y value is always going to be 0. And then whatever x value we have. So, in order to solve for the x-intercept, right, I let y equal 0. In order to sign for the y-intercept, I let x equal 0. So I'm going to go ahead and find the x-intercept and the y-intercept. I'm going to write them as ordered pairs, graph them, and draw a line between them. So let's start with x first. So I might shorten that to x-intercept. You can't see that blue on that gray very well, can you? Let's change it. How's orange? So I have the x-intercept. See, that's so much better. So that's when y is 0. So I have 4x minus y, which is 0, equals 3. So I have 4x equals 3. I need to get the coefficient on my x to be a 1, right? So I have x all by itself. So I have x equals 3/4. So my x-intercept is when x is 3/4, y is 0. Okay, I've got 1 point. I can graph it. So when x is 3/4, that's like right here, y is 0. So here's my x-intercept. Now I need to find my y-intercept. So that means I'm going to substitute in 0 for x. So now I have 4 times 0 minus y is 3. 4 times 0 cancels out. That means I have negative y equals 3. But I'm not done yet because I want the coefficient on y to be a positive 1, not a negative 1. So I can go ahead and divide both sides by negative 1, or I could have multiplied both sides by negative 1. It would have given us the same answer. And I get y equals negative 3. So I now know when x is 0, y is negative 3. So here I go to where x is 0, go down 3, and there's my point. So I have when x is 0, y is negative 3. Because I have 2 points on my line, you guessed it, I can graph it. Okay, so here I have the graph of my line, and friendly reminder that every single point on this line, if we'd drawn it really, really well and plugged it in, would satisfy this equation.